Welcome to yet another video of Code from Scratch. So proud of you for showing up today. I highly suggest you that you keep commenting that okay, you are present. So what will happen is you will end up motivating each other also, and I will somehow remember your name that okay, you are showing up every day. And what we are going to do in the end is I'm going to take some of you and we are going to do mock interviews together on the channel. So keep commenting and keep showing up every single day. I am so proud of you. Also, some of you had doubts about how binary search is being applied in an unsorted array in yesterday's video, and I completely get it, and that is why that question was so important and tricky. We will do some more questions on binary search, and what I'll do after that is I'll make a dedicated video on how you can identify that okay, binary search has to be used for these questions. I'll share some tips and tricks that will help you identifying that okay, binary search has to be used. But for now, I recommend that we practice a few more questions so that we are very clear with binary search concepts and we know that okay, it is being applied in such and such way in such and such questions. So without any further delay, let's get to today's question. So the question says that you're given a sorted and rotated array. So earlier there was an array which was sorted. It was now rotated at a particular point. There are all distinct elements present and it is rotated at some point. You are given an element k. Your task is to find the index of the given element in the array. Okay. And it is given to us that we can return -1. So it is not necessary that the element has to be present. If it is not present, then we have to return -1. And then expected time complexity is order of log n. See, even if expected time complexity is not given to you, we should be able to identify the questions. That's first point. Secondly, we can understand that from the constraints given to us sometimes that, okay, the constant is of the power 10 power 5 or 10 power 6. Then we know that, okay, we can apply binary search over here. Let's now take the example and let's try to see how we can solve the question. So this is the example that is given to us. As you can see, this array has been rotated around the point 10. So this is basically the pivot. Our original array would have looked like 1, 2, 3, 5, 6, 7, 8, 9, 10. And then we decided we are going to rotate it and we are going to take these three elements on this side. So now what we are going to do is we are going to make some observations and try to come up with a solution, right? So let's try to observe what is true for this particular array. Basically any sorted array which has been rotated at one point. Okay, so suppose we take any element, pick up any element over here. Say I pick up the element 8. Okay, I know that one of the two arrays on the both sides, like say left array and right array, one of the two arrays will definitely be sorted. Why is that? See, our pivot is over here. So if this side is not sorted, we are sure that okay, this side would be sorted, right? Because we have rotated only once. So suppose the pivot is present over on right side, then we know that okay, left side is at least sorted for sure. Similarly, if we pick up say any other element, we pick up the element 2. We know that okay, the pivot exists on this side, on the left side. So okay, the left side is not sorted, but at least the right side is sorted. Okay, so we know that whenever we pick any element over here, say I pick up the element 9, this side is sorted, this side is not sorted. You can take any examples of not just this array, any array, and you try to rotate at one point, you will always observe that one side is sorted and one side is not sorted. So this is one observation which is extremely important. Try to take more and more examples if it is not obvious to you. Rotate at one point and take any element from that array and see that okay, either left side or right side will always be sorted. That is number one observation that we have done. Okay. Now that we know that at least one side will be sorted, now let's see how can we use that. Okay. Now let's say we pick up the element 9. We know that left side is sorted. We know that right side is not sorted, right? That is one thing that we know. Left side is sorted, right side is not sorted. Now say we want to search for an element k. It is very easy to see whether the element k exists in the sorted part or not. See, we know that, okay, what is the least element of the sorted part? We know what is the highest element of the sorted part. It is very easy to check whether k will exist on this. If k is greater than 5 and if it is less than 8, we know that, okay, k exists over here and it exists, okay? Say if we know that, okay, k is greater than 8 or if k is less than 5, then we know that it will not exist on the left side. Then it is possible that it exists on the right side, right? So again, to repeat that, first thing that we noted was that we know that, okay, if we pick any particular element, one side of the array will be sorted, one side of the array will not be sorted. Now, since one side of the array is sorted, it can be left side or it can be right side. we can know whether our element exists on that particular sorted side or not. It is very easy, right? We just have to compare the smallest and the biggest element with the element k that we are searching for. Okay. Now, if we find the element over here, then what we have to do, we just have to do normal binary search, right? Suppose we do not find the element over here. Then what we can do is, we know that our answer exists in the right side. So now earlier we were searching in this space. Now instead of searching in this space, we can search in this space. Basically, whatever happens, we can always reduce our search space from n to n by 2 to n by 4 to n by 8. This is the entire concept of the question. And once this is clear, I am sure the writing the code part will be very, very easy. So that is why I'm emphasizing again and again on the point. First, we have to identify that, okay, which part of the array is sorted. Pick any element, okay? Because we are going to use binary search, what is the most efficient way to do it? We pick the middle element, okay? Let's take more examples. Let's try to dry run and see. But let's say instead of picking 9, instead of picking the middle element, I had picked 2. Suppose this is my middle element that I'm considering, okay? I know that this part is not sorted and this part is sorted. How do I know this part is not sorted? Because this element is greater than this element. Obviously, then it is not sorted, right? So it is very easy to see whether the half of the array is sorted or not sorted. So here we know that this is not sorted. This part of the array is sorted. Now, since this is sorted, I can check whether my k exists in this part or not. Right now, there is one element only. But say there were more elements. Say there was 5, say 5 was not present over here, say 5 was present over here. Then I can check that, okay, k exists in this part or not, okay? Suppose it does not exist. If it does not exist, I will have to do my search again in this part. If it exists, I will have to do my search in this part. If it is not clear yet, don't worry. We will try to write code properly, handling all the cases. And after that, we will dry run again to understand it better, okay? So let's try writing the code now. This is the vector that is given to us and this is the element that we have to find. Okay, so first let's find the size of the vector. So let's write that as vec.size. And now what do we have to do? To apply the search, we have to take 2 pointers. So we take a lower pointer, which is 0, and the higher pointer is n minus 1, right? And we will also need a middle pointer, like a middle element where we will be searching, right? So now what will be the while loop? By now, I guess all of these basics must be completely clear. So our while loop is L less than or equal to H. So this is where we will do the search. Now, if we find the element, we will end up returning it from inside the while loop itself because we will end up returning the mid value. We have to return the index. If we do not find it, we are going to return -1 outside when we will come out of the loop. Okay. So this is where we are handling returning -1 if the element is not found. Okay. Now let's try writing the while loop. First thing that we have to do is find the middle element. And how do we find it? I hope none of you are writing L plus H by 2 now. If this is not clear, again, go and watch the second tutorial video. Okay, we have found the middle element. Now, if the value present at this middle index is k, we can just return the answer from there itself, right? We have found the answer. So what we are going to do, if vec of mid is equal to k, we are just going to return mid from there itself, right? Otherwise, what do we have to do? Now, that is not our answer. So, we know that our either left array or the right side of the array is sorted for sure. Okay, now how can we check whether the left array is sorted or whether the right array is sorted? Left of what? Left of this mid value. So, we are at middle point. Either the left side will be sorted or the right side will be sorted. So, how can we check that? See, if vec of L, basically the lower point, is less than vec of mid, then we know that left side is sorted. Left side is sorted. And how is that? See, how does our array look right now? It's like L will be a point, then after a point there will be mid, then after a while there will be H. Okay, so if vector of L is less than vector of mid, then we know that, okay, this side is definitely sorted. Otherwise, what will happen is vector of mid will be less than vector of H. We don't actually have to write this because we know that our array is rotated at one point only. So that is why we don't need to check. Otherwise, we could have done it opposite way also. We could have written our if condition as vector of mid is less than vector of H, then our right side would have been sorted and we could have written this in else part, right? Anything is fine. Different people will write code in different way. We are writing that, okay, the condition for left part being sorted. Another thing to notice, why am I writing less than and not less than equal to? Because we are given that distinct elements, so we don't have to bother about equal to condition at all. We are given that, okay, elements will be distinct at all, completely. So these are the small things that you need to notice in your examples, in your questions, because you need to handle all the edge cases. So we have to take care that, okay, elements can be equal or not, or are they distinct, okay? So here we know that left part is sorted, and here in the else condition, right side will be sorted. See, one of the two will always be true. So that is why we can write the else part itself. If we wrote the condition for right side being sorted, then our left side being sorted could have been in the else part. One of the two will definitely be sorted. Now, if the left part is sorted, okay, how do we check that, okay, our k element is present in the left part or not? So for that, what will happen? Our basically vector of L should be less than equal to k, and vector of mid should be greater than k. Okay, now another thing to notice. So basically k value should be between vector of L and vector of mid, or better way to write, by which it will be better clear. I'm writing the same thing, but just another way to write it so that, it looks more presentable. Vector of L less than equal to k less than vector of mid. See, here I don't need to write less than equal to. I can write it also. It won't matter, because if it was equal to, I would have just written mid from here itself. That is why notice the small details. Here equal to condition should be there, because if it is equal, I need to go to the left side. Okay. So I know that, okay, it is present on the left side for sure, because left side is sorted. So what am I going to do? I'm going to reduce my search space to the left side now. So what I'm going to do, I'm going to make my h as mid minus 1. See, it was sorted and our k existed on the left side. So I have reduced my search space to the left half. Okay. But even if this was sorted and we know that it is not present on the left side, then we know for sure that it is present on the right side. Okay. So what we are going to do, we are going to do else L equal to mid plus 1. Okay. Again, see, left part is sorted. We check whether it is present on left side or not. If it is present on left side, so reduce search to left side. Okay. If it is not present on the left side, we are sure that it will be present on the right side. So reduce search to right side. One of the two it will be present, right? So if it is not present on the left side, we will check on the right side. If it is not present on the right side also, we will in the end come out of the while loop and we will return minus 1. Okay. So if it is not present on the left side, we have to search on the right side. Similarly, we have now come to the point where right side is now sorted. So if right side is sorted, we will check whether the element exists on the right side or not. So what will be the condition for that? So if vector of mid is less than k and k is less than equal to vector of I. See, now again, here I am adding equal to. Here I could or could not add equal to, because middle point, if it was equal, I could have just written the answer from there itself. See, here I have to add equal to for sure, because I don't want to miss the case where k value will be equal to vector of h. So if this is the case, then we know that the right side is sorted and k element is present on the right side. So since it is present, what I'm going to do, I'm going to reduce my search space to now right side. So here I'm going to write reduce search to right side. Otherwise, what we will do? Otherwise, we will reduce it to left side. See, again, in this case, right side is sorted. If right side is sorted, I check whether my k is present on the right side or not. If it is present, then we are going to reduce the search space to right side. If it is not present, then we are going to reduce our search space to left side. Our code is done. Let's compile it and see whether it works or not. Okay, let's try to submit it. Works like a charm. Let's try to dry run also with the code itself, so that, okay, it is completely clear and there is no doubt at all. So let's try writing the L and the H value over here, and we will write the mid value over here. Okay. So L value initially is 0, H value initially is 9 minus 1, which is 8. So what our mid value will be? It will be 4, right? So what is the middle value? 0, 1, 2, 3, 4. So 9 is our middle value. Now we compare, is vector of mid, which is 9, equal to k? Now it is not. Okay. Now we check whether our left side is sorted or right side is sorted. So we check that, okay, vector of L is less than vector of mid. So 5 is less than vector of mid. So we know that, okay, left side is sorted, right side is not sorted. Okay. So since left side is sorted, we are going to be in this if condition. Now we check whether k is in between 5 and 9 or not. So k value is what? 10. Okay. Is vector of L, which is basically 5, 5 is less than or equal to k? Yes. But is this also true? No. Our k value 10 is greater than 9, right? So our k value doesn't exist on the left side. So now we have come over here. So now our L value has become mid plus 1, which is basically 5. So we have now reduced our search space to 5 to 8, right? So now we are searching within these 4 elements. What our mid value is going to be? 13 by 2, which is 6. So basically our vector of mid value now is 1. So now we check that, okay, our left side is sorted or our right side is sorted. So our left side only L is there. So is vector of L less than vector of mid? No, that is not the case. So we know that our right side is sorted and not our left side. So we are going to come over here. Now, since right side is sorted, what are we going to do? We are going to check whether our k value exists between these 2 points or not. Is vector of mid less than equal to k? Less than k? No, it is not true. So we are not going to move towards right side. We are going to move towards left side. So now our h is going to become mid minus 1, which is basically 5. We have now reached the condition where both L and H values are 5. So our mid value will also become equal to 5. And now we have come to the place where vector of mid is equal to k. So we end up returning the mid from here itself and we have found our answer. Similarly, I highly recommend you to take more examples to proper try run, understand why we are reducing the search space to either left side or right side, okay, and then try understanding how we can apply binary search to more questions. We will take more questions and it will be completely clear. If you're struggling right now, it's fine, just practice more. And you're doing great by showing up every day. I'm hoping to see you tomorrow. I will remember your name if you comment. I promise I will. So thank you so much. Tata.